Welcome to Study Loop.
Welcome to the problem number 22.56. This is chapter 22. Go slow. So in this question we are given a sphere, and this sphere has non-uniform charge distribution and has row charge density which is equals to this. So for r less than r we have this much density, and for r greater than there is no density. That means the charge is contained within this sphere which has capital R radius, and we are given that this quantity is constant, which is rho naught. So first we need to find out the charge contained within the this volume, and then we will find out the electric field, and then we will go on to the D and C and C, D, E and part. So let's find out the charge contained. So we have charge contained, which is Q equals to rho times dV, which is the volume charge density times multiply volume, which gives the total charge. So we have, this is a sphere, so this would be rho r times dv. Dv is equals to 4 pi r square dr. So this gives us rho 4 pi r square dr. So put in the value of the rho. So this rho goes from 0 to r. So we put it 0 to r. So we have 4 pi rho naught 0 to r 1 minus 4 r over 3 capital R square dr. So doing the integration we have 4 pi rho naught r cube over 3 minus 4 3r r4 over 4. So this goes away, so this is 3 and 4 goes away, so this comes out to be 4 pi rho naught r cube over 3 minus r cube over 3 equals to 0. So total charge contained within this volume is 0, but it is distributed over the whole sphere, and we have a minus sign, and this says something. So that means some has negative charge and some has positive charge within this volume, but total charge is 0. So that's your A part. Now going to the B part, so we need to find out the electric field at R greater than capital R. So we have Gauss law, so E dot ds equals to Q enclosed over epsilon naught. So we have Q enclosed, total charge contained within this volume, because we are talking about point outside the sphere. So this is our Gaussian surface now. So total charge is we have already found, which is equal to 0. So which is equal to 0. And this is a symmetric configuration. That means we have E equals to 0. So the electric field outside is 0. Now going to the part C. Now we need to find out the electric field R less than capital R. So which is E dot ds Q enclosed over epsilon naught. Now take a look at the surface again. So this is our capital R radius. Now we make a Gaussian surface which has radius small r. Now we have Q enclosed. So Q enclosed would be rho dV. The dV is the area of this, or the volume of this smaller sphere, which is equals to rho 4 pi r square dr, starting from 0 to r. And we can put the value of the rho, which is this one. So this comes out to be 4 pi and rho naught r square dr, starting from 0 to r, minus 4r cube over 3 capital R dr integration 0 to R, and that would be your total enclosed charge. So whatever the quantity we have here, so we should replace with the quantity here. So E dot ds, now ds would be the area of the this sphere, which is 4 pi r square equals to q enclosed, which is this quantity over epsilon naught. So this gives us E equals to 4 pi rho naught, this quantity over 4 pi r square mu naught. So we have this integration now, r square. So let's integrate it out if we want to integrate. So let's this integration will give us r cube over 3, and this integration will give us r4 over 3r. So this gives us equals to, so the 4 pi goes away, and this gives us exactly result equals to rho naught over 3 e naught times r 1 minus r over r. So that's your answer for your part C. So the electric field within the sphere at distance r from the center of the sphere. Now going to the part D now. Now we need to plot the electric field versus r distance. So this is our r and this is our er. So if you take a look at the this graph, and you can use the Excel to plot the graph, or you can use some online or maybe some program Mathematica to plot the graph. So the graph comes out to be like this one. So the maximum is equals to some value, and we will find out the maximum in part E. So let's do the part E parallelly. So we need to find out the maximum of this electric field. So let's take the derivative of electric field and with respect to R. So the maximum gives us derivative of the electric field with respect to R equals to 0. So this is the condition for the maximum condition. So this is the maximum, gives us the maximum. So this comes out to be rho naught over 3 e naught 2 rho naught r max 3 e naught r equals to 0. The r max is the point where the electric field is maximum. It's distance from center where electric field is max. Therefore, this gives us R max equals to capital R over 2. That means we have at the center. That means at the halfway of this one, we have electric field maximum. And this electric field we can find out. So put in the value of the R equals to R over 2. So E equals to R over 2 equals to give us rho naught over 3 E naught R over 2 1 minus 1 by 2. So this gives us rho naught capital R over 12 E naught. So which is equal to this maximum value. So this is equals to rho naught capital R over 12 E naught. So that's your answer for this question. Thank you for watching the video.